Welcome to The Explainer. Today, we're going to break down a really fascinating patent for a whole new kind of nuclear fuel. It's a technology that's trying to solve some of the oldest challenges in nuclear power with, well, a surprisingly elegant twist.
So just imagine this for a second. What if you could walk up to one of our existing nuclear reactors and just by swapping out the fuel, get a 30% power boost? I mean, that's a massive leap in energy from the exact same plant.
And here's the kicker. What if that very same change also made the reactor fundamentally safer to operate? So you're getting more power and more safety. That sounds almost too good to be true, right? So the big question is, how on earth is that possible?
Okay, let's get into it. To really understand why this new design is such a big deal, we first need to take a look at the fuel we've been using for, over half a century.
All right, so here's the way we've always done it. For decades, nuclear fuel has come in this standard shape. It's a long, thin metal tube, and it's packed with these little ceramic pellets of uranium oxide. It's been the reliable workhorse of the industry for sure, but it has some pretty deep-rooted limitations.
And the craziest part is that a huge engineering problem comes from a basic fact of geometry. The heat is generated inside the rod, right? But it can only escape through the surface. And a cylinder, well, it's just about the worst shape you could pick for getting that heat out fast.
And that one simple fact creates this whole cascade of problems. That low surface area means heat gets trapped. This, of course, raises the risk of overheating, which forces reactors to run cooler than they otherwise could. And to keep hundreds of these rods from bumping into each other, they're held in place by these complex grids, kind of like an egg carton, which, get this, also get in the way of the water you need for cooling. So how do you solve all of that at once?
Well, to tackle this challenge, a company called Lightbridge just completely reimagined the fuel rod from the ground up. They didn't just tweak it, they changed its fundamental shape, its material, everything.
First thing they did, they got rid of the cylinder. The new design has this really distinct four-lobed profile. And right away, you can just see how this massively increases the surface area compared to a simple circle of the same size. More surface means better cooling. Simple as that.
Second, they changed what it's made of. Instead of ceramic pellets rattling around in a tube, this is a solid rod made from a uranium-zirconium metal alloy. Now this is a total game changer, because metals transfer heat way, way better than ceramics. It's a huge advantage for getting that heat out into the coolant, where it can do some work.
And finally, here's the masterstroke. The entire lobed rod is given a helical twist, kind of like a piece of licorice. And trust me, this is not just for looks. This twist is the magic that makes the whole design really sing.
Okay, so let's break down how this brilliant combo of shape, material, and twist adds up to some truly game-changing performance. This is where it gets really cool.
And this is what I love about great engineering, when one single design solves a bunch of problems all at once. The multi-lobed shape, that boosts your surface area for better cooling. That helical twist, it actually makes the rod self-spacing, so you can get rid of those flow-blocking grids. Plus, it forces the water to swirl around, which improves heat transfer even more. And the solid metal alloy not only moves heat better, but it also physically traps dangerous fission gases inside its structure.
And when you put it all side by side like this, you can really see the total transformation. It's like every single weakness of the old fuel has been turned into a strength. Low surface area becomes high. Inefficient heat transfer becomes super efficient. The risk of overheating goes way down, and you don't need those spacer grids anymore. It's just an elegant solution.
So what's the bottom line here? The crucial point is this. With all these improvements, you could run a reactor hotter and harder. The analysis in the patent suggests a power increase of up to 30%. That is like getting a whole new power plant for the cost of just a fuel upgrade.
But okay, what if you don't need more power? Well, if you run the reactor at its original power level, the fuel's surface temperature is about 30% lower. This gives you an enormous boost in your safety margins, making the whole system much more resilient.
And speaking of safety, check out this quote directly from the patent. In conventional fuel, dangerous gases can build up and potentially get out. But here, the fission gases are physically trapped, or entrained, as they say, within the solid metal itself. They are locked in. They just don't escape, which is a massive safety enhancement.
Now, this isn't just some clever idea on a whiteboard. Lightbridge is actively moving this technology from the patent office into the real world, toward an actual power plant.
Development's been chugging along since that first patent back in 2014, but the really big one to watch is late 2025, when real-world material testing is set to start at the Idaho National Laboratory. And just recently, they even locked down another patent to use this fuel in CANDU reactors, which is a whole other market.
And that is a huge deal because this tech is designed to work in the world's most common reactors, the pressurized water reactors or PWRs, as well as that fleet of over 30 CANDU reactors operating around the globe. This isn't some niche product, it's targeting the absolute mainstream of nuclear energy.
Of course, Lightbridge isn't alone in this. There's a global race to develop what everyone is calling accident-tolerant fuel. A lot of companies, like Framatome and Westinghouse, are focusing on adding tougher coatings or new shells to the old fuel rods. Others, like Rolls-Royce, are making these tiny fuel particles that each have their own containment. It's a field that is just buzzing with innovation. But Lightbridge's approach of redesigning the fundamental geometry of the fuel, that's a truly unique angle.
So what this all really comes down to is a powerful lesson in how rethinking one core component can have this huge ripple effect across an entire industry. A simple twist, combined with modern materials, could unlock a whole new era of performance and safety for the nuclear reactors we already have.
And that leaves us with one final, pretty powerful question. At a time when we need more clean, reliable energy than ever before, could a simple, elegant innovation like this twisted fuel be one of the keys to actually reshaping our energy future? It is definitely something to think about.